This is a key to Radicals number 4 worksheet. And in this case, in these problems, you're going to be adding or subtracting. These are all square roots. And then for problems with the asterisk, show work. And make sure you're showing the product rule being used. All right, now, in this worksheet, all the problems contain variables in the radicands. And so we need to be careful with those. All right, so let's look at number 1. I'm going to go ahead and just use another sheet of paper to do the work. Now, number 1, we have 2 square root of y plus 6 square root of y. All right, so notice when we talked about square roots before, since the radicands are the same, they both contain the variable y. All right, and then remember, with radicals, if the indices are the same, in this case square root, the index is 2, then you can combine them as long as the radicands are the same as well, and they are. So I have 2 square root of y's plus another 6 square root of y's will give me 6, 7, 8 square root of y, right? So the answer is 8 square root of y. All right, so that's number 1. Number 2, we have 4 square root of x plus, minus 9 square root of y minus 6 square root of x plus 2 square root of y minus square root of x. All right, so notice that in these radicands, the variable x, that's being raised to the first power. Now, I cannot simplify that just like this. See, I could not simplify the square root of y. So whenever you have a variable raised to a power in the radicand, you cannot simplify this if the exponent is less than the index. So 1 is less than 2. So that's why I didn't go any further other than just combine like terms. Same thing here. The square root of x to the first, square root of y to the first, square root of x to the first, square root of y to the first, square root of x to the first. I cannot simplify any of those. All I'm going to do now is just combine like terms. So let's talk about the square root of x. So I can combine the square root of x, negative 6 square root of x, and negative 1 square root of x. So let's do it in order. What's 4 and a negative 6? So 4 and the negative 6 is a negative 2, right? And what's the negative 2 and a negative 1? Well, that's a negative 3. So if you need to, well, I want to remind you about this. So we have 4 square root of x minus 6 square root of x minus square root of x, right? So I have these 3 terms. So the GCF is square root of x. So if I want to factor out the square root of x, I can, and I'm left with square root of x times 4, square root of x times a negative 6, and then the square root of x times a negative 1. And then notice if you need to use your calculator. So some of you still have a little issue with signed numbers, so use your calculator. You have access to a calculator. But you really want to understand those signed numbers, so don't, at some point, make sure you go back and you review how to add and subtract signed numbers without using a calculator. So we have 4 minus 6 minus 1, and notice you get negative 3. So it's going to be negative 3 square root of x. So that goes here. And then we're going to do the same thing, and just make sure that the x is under the square root now. And so we have a negative 9 square root of y and a positive 2 square root of y. So that's going to be a negative 7 square root of y. And so that's the answer to number 2. Number 2, we have, let's see, I may have written something wrong. So that minus 4, plus 6, right? So that should be plus 6. So again, be careful as you write things. You can easily mess up, and on a quiz or a test, you're going to lose points. So let's go back and fix this. So this will be plus 6, correct? And so 4 plus 6 is 10. 10 minus 1 is 9. So that's going to be a 9 square root of x. So let me fix this. So it'll be a 9 square root of x minus 7 square root of y. So that's correct. So 9 square root of x. Good Lord. All right. So x, 9 square root of x minus 7 square root of y. All right. Number 3. Number 3, we have the square root of 64 times x. Notice the x is in the radical, in the radicand, plus the square root of 25 x cubed. All right, so be a little bit careful as you go through this. So let's use a product rule here. So according to the product rule, that's going to be the square root of 64 times the square root of x. And then over here, that's going to be the square root of 25 times the square root of x cubed. Now let's simplify what we can. So in this factor, the square root of 64, I can simplify. 64 is a perfect square, so that's 8. So I get 8 square root of x. I cannot simplify the square root of x, so the exponent is 1, and 1's less than 2. Over here, that's 20. That's going to be 5. Now let's talk about the square root of x cubed. I can simplify the square root of x cubed because 3, the exponent, is greater than or equal to the index. So we use a product rule. So we're going to rewrite this as square root of x squared times the square root of x. All right, now coming back and simplifying this one here. So I'm going to get 8 square root of x plus 5. The square root of x squared is just x, square root of x. All right, now let's talk about if those are like terms. You may say those are like terms because they both have a square root of x. Well, you got to be careful. So you also have to look to see if there are any other factors that's a variable, and there is. See, there's an x here. So you would need to, in order to determine those are like terms, you need to ask yourself, I have an x times square root of x in this factor, in this term. Do I have an x squared of x in this term? The answer is no. So they are not like terms. That's all you can do. So you have to look and see if there are any other factors of x besides that square root. So if this x wasn't there, then yes, those are now like terms. So 8 square root of x plus 5 square root of x, you can combine those. But the fact that you have a factor of x makes those now not like terms. All right, so you cannot do anything else. There's your answer. All right, so the answer number 3 is going to be 8 square root of x plus 5x square root of x. Okay? All right, so that's different than this one. See, there I can combine, but the fact here is that there's an extra factor of x here, and there's not one here. All right, number 4. So number 4, we have the square root of 81 x plus the square root of 64 x minus the square root of 36 x. All right, now using the product rule, this becomes the square root of 81 times the square root of x plus the square root of 64 square root of x minus the square root of 36 times the square root of x. And then I can simplify each of these right here. I cannot simplify the square root of x's for the same reason we talked about here. The exponent was 1, 1's less than 2, so that's as simplified as it can go. But here I can write square root of 81 as 9, so get 9 square root of x, plus this one's going to be 8 square root of x, and then 6 square root of x. And now notice those are all like terms. Those 3 terms are like terms. So all you have to do is just add their coefficients. So 9 plus 8 minus 6 gives me 11. So the answer is going to be 11 square root of x. All right, so that's the answer to number 4. So we get 11 square root of x. All right, let's look at number 5. Number 5, we have this in number 5. We have 4 times the square root of 4y to the 5th minus the square root of 25y to the 5th. All right, and so according to the product rule, I can rewrite this. As 4 square root of 4 square root of y to the 5th minus square root of 25 times square root of y to the 5th. All right, now you may say, well, since those square roots have the same radicand, do I have to simplify them? Yes. Yes, you must simplify your radicals. You must simplify the square roots as much as you can. All right, so we have 4 times the square root of 4 is 2, right? Now, let's talk about the square root of y to the 5th. So we got to rewrite this now because 5, the square root of y to the 5th, I can simplify. 5 is greater than or equal to the index, which is 2. So always use the largest even number that's less than 5 to rewrite this. So it'll be the square root of y to the 4th times the square root of y. Minus, and it would be square root of 25 is 5, and then I get the same thing, square root of y to the 4th, square root of y, using the product rule. And so now I get 4 times 2 is 8. The square root of y to the 4th is y squared, square root of y, minus 5 Square root of y to the fourth is y squared, square root of y. Now, here's the thing. Are those like terms now? Remember a while ago in number, which one was it? Number 3? Those are not like terms because of that extra factor of x here that you didn't see in here. But notice that the square roots, the radicands are the same, and they both have that y squared factor. And so now those are like terms. See, those are like terms. And so now all I have to do is just, in this case, add their coefficients. So 8 and then -5. So 8 subtract 5 will be 3y squared, square root of y. And so that's the answer to number 5. So 3y squared, square root of y. All right, number 6, 7, and 8 require work. So it's this idea here. All right, so let's go to number 6. So number 6, we have -11, square root of 18 m, and m is part of the radicand, plus 4 square root of 8 m. Okay, using a product rule, I can rewrite the square roots as -11 times the square root of 18 times the square root of m, plus 4 times the square root of 8 times the square root of m. And then let's go about the square root of 18. The largest perfect square that goes in 18 is 9, so I can rewrite this as -11 times the square root of 9 times the square root of 2, because 9 times 2 is 18, times the square root of m, plus 4. Okay, over here I'm going to use 4 as the largest perfect square. Square root of 4, square root of 2, square root of m. Okay, so 4, square root of 8 is square root of 4 times 2, and then I have the square root of m. All right, now let's simplify what we can. -11 times the square root of 9 is 3 times the square root of 2. I cannot simplify the square root of 2 because the only perfect square that goes into 2 is 1 times the square root of m, plus 4 times 2 times the square root of 2 times the square root of m. All right, now at this point, you want to rewrite this as one square root, both cases. All right, so a -11 times 3 is a -33 times the square root of 2m. Notice the m is in the radicand, so you got to make sure it looks like that. Don't write it to where there's some ambiguity. You got to make sure that it's noticeable that m is a radicand as part of the radicand. 4 times 2 is 8, so I get 8, and the same thing, square root of 2m. And now those are like terms because the indices are the same. They're both square roots, and the radicands are the same. So a -33, and a +8 will give me a -25 square root of 2m. So that's the answer to number 6. So number 6, we have -25 square root of 2m. Okay? All right, let's talk about number 7. So number 7, here's what we have in number 7. Let's get another sheet of paper. So here's number 7. All right, so number 7, we have 2 square root of 20 x to the third minus 2x square root of 80 x. All right, so using a product rule, I can rewrite this as 2 times the square root of 20 times the square root of x cubed minus 2x times the square root of 80 times the square root of x. Now let's simplify each of these. So I can rewrite, make sure you write down the 2. So I can rewrite 20 as the square root of 4 times the square root of 5. 4 times 5 is 20. And again, I can simplify the square root of x cubed because the exponent of 3 is less than or equal to 2. I'm sorry, it's greater than or equal to 2. So I can rewrite this as square root of x squared. Always use the even number. That's the largest even number that's less than the exponent of 3. All right, so always make sure you get this back. Square root of x squared times square root of x is x cubed. Square root of x cubed minus 2x. For 80, the largest perfect square that goes into 80 is 16. So I can write this as square root of 16 times the square root of, what's that, 5? And then the square root of x. Okay? Now let's simplify all of these as much as we can, each of those factors. So 2, the factor of square root of 4 is just 2. So 2 times 2. I cannot simplify the square root of 5. The factor of square root of x squared, I can simplify that. That's even. So that's the easy kind. So that's just x. And then square root of x. minus 2x, that's going to be times 4, right? Times the square root of 5 times the square root of x. All right, so let's rewrite this as much as we can. 2 times 2 is 4, and then times x, this x here. Now, remember, you want to rewrite this as one square root. So the square root of 5 times the square root of x. Remember, you can multiply square roots by just multiplying the radicands. So that'll be 2 times 2 is 4. So get 4 times this x times the square root of 5x. I always put the square root on the end. Minus, and then over here, that's 2 times 4 is 8. So get 8x. And then the square root of 5 times the square root of x is the square root of 5x. Now, the question becomes, are these now like terms? The radicands are the same. They both contain 5x. The index is the same. They're both square roots. And then notice that extra factor of x here, and I have it here. So 4 of these, x squared of 5x, minus 8, of these, will give me a negative 4 of those. So negative 4, x squared of 5x. All right, so that's the answer to number 7. So negative 4, x square root of 5x. All right, and then finally number 8. So number 8, we have 3 times the square root of 72x squared. Notice I'm extending my radical symbol. Minus 3 square root of 50x squared minus 8 square root of 18x squared. All right, so let's use the product rules. I can rewrite this as 3 times the square root of 72 times the square root of x squared. All right, using a product rule. Minus 3 square root of 50 times the square root of x squared minus 8 square root of 18 times the square root of x squared. All right, now let's talk about the square root of 72. So the largest perfect square that goes into 72 is 36. And so I get 3 times the square root of 36 times the square root of 2. And then let's go ahead and simplify this right now since that's the exponent's even. So the square root of x squared is just x. Minus, and then 3 times, that'll be the square root of 25 times the square root of 2. And again, the square root of x squared is just x. Notice when I rewrote it, see how it doesn't look like it's part of this radicand 2. Okay, so be careful. Minus 8, and then square root of 18, that'll be the square root of 9 times the square root of 2. And then square root of x squared is just x. All right, now let's simplify what we can again. So that 3 times square root of 36 is 6. Square root of 2 times x. Minus 3 times square root of 25 is 5. Square root of 2 times x. Minus 8 times square root of 9 is 3. Times square root of 2 times x. All right, now let's write this a little bit better. So 3 times 6 is 18, and we're going to put the square root of 2 at the end. So I get 18 times x times the square root of 2. So 18x square root of 2. Minus 3 times 5 is 15. Same thing here. 15x square root of 2. Minus, and then 8 times 3 is 24. So get 24x square root of 2. So notice that all of these are like terms. They all have the radicands 2, and they'd have that extra factor of x in all of those. So all you have to do is just add their coefficients. So 18 plus a negative 15 plus a negative 24 equals a negative 21. So I get a negative 21 x square root of 2. And so that's the answer to number 8. So negative 21 x square root of 2. Notice I have the radical on the end. That's always a good idea. All right? Because here's the situation. If you wrote it as negative 21 square root of 2x, you better make sure that that x doesn't look like it's part of this radicand 2. All right, so this is incorrect. If you do that, don't write it as so close to where it looks like that. All right, so you got to be careful. All right, so that's why it's always a good idea to put the square root on the end. All right, so that is the key to worksheet number 4.